Where you're in the woods.
I have no idea what's going on here. Okay. No, it's not broken. I was just going to try to... There we go. Okay. I was going to try to make a better recording this block than I did first block. So far, it's not looking like it's going to happen. Okay. You do a linear regression to look for a correlation between your two pieces of data. Okay? Now, this is important. Correlation does not tell you causation. It just tells you these are directly related to each other. It does not tell you which one causes the other. Huh? Okay? When you do a linear regression, that line you get can be called a line of best fit. It can be called a trend line. I think on the LabQuest, it's just called a linear fit. But what it is you have your data, and you know you've got a scatter of points, and your line of best fit is your line of average through it. It's giving you a visual average. It's giving you the trend. It gives you the ability to say, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so let's just put some random numbers on there. Some random numbers on there. Okay, it gives you the ability to say, well, I did not measure this, but what would it be? You know, you can make predictions using the line. Huh? So how are we actually going to do the linear regression in the calculator? You've entered your data. Okay, so what I want you to do is I want you to hit second and the 0 to open up the catalog. Okay, and then I need you to hit this x to the minus 1 because you're on alpha lock once you're in the catalog, and that's the letter D. So you're going down here and you are looking for diagnostics. Okay, so see how you have diagnostic off and diagnostic on. D-I-A-G, just keep scrolling down through the D's. Okay, put the little arrow by diagnostic on, hit enter, that pastes it to your command screen, hit it again, it'll say done. Okay, you need diagnostic on. Okay, now you put your data in. So you've got your data in. You want to see what that data looks like. Second y equals to go into your stat plot. Turn plot 1 on. Make sure it's that first one with all the little dots, your scatter plot. Your x is in list 1. Your y is in list 2. And then you can hit graph. And yours will not have a line yet. I didn't clear my line from last block. Okay? Now, if it isn't showing, what do you do if it's not showing? If you can't see your graph, zoom and then 9 to auto zoom. Interesting. Error window range. If you are getting an error and it says the dimensions, it says fixed dimensions in window. So do you see right next to zoom, it says window? If you click on that, do you see how it lets you put in a minimum x, a maximum x, a minimum y, and a maximum y? You just enter ones that fit your data. And that fixed it when I just fixed it for Jonathan. So I'm hypothesizing that you can always fix it that way. So just put in your lowest X and your highest X, and then you literally could put in your lowest Y and your highest Y, or you could, for either of them, you could go a little bit outside it, but that should fix it. All right, so how to actually do the linear regression. Click Stat and go over to Calc. Choose number 4, which is linear regression. So you want your X to come from list 1, your Y to come from list 2, and you want to see that line. You honestly do not need to see the graph to decide what type of correlation you have. It just makes a whole lot more sense to look at it. So you want to store that regression equation so that you can see the line. So put your cursor down by Store Regression Equation and hit vars. Vars is kind of just under the little 4 directional arrow. Okay, now go over to Y vars and click on 1 for function, and then click on 1 again for Y1. So what that means is it's going to store your equation as Y1 equals. Now go down to Calculate and look what it's giving you. It's giving you Y equals AX plus B. Looks exactly like Y equals MX plus B. For some reason, the calculator wants to use an A for slope instead of the M that we've been learning since pre-algebra. But that's okay, we can adjust. So it gives you your slope, it gives you your y-intercept, and then it gives you r squared and r. If we had not turned diagnostics on, you would not have gotten that r value. And the r value is important. Okay? Look at this. Okay? Your r value is your Pearson correlation moment. Your r value is how tight does your data fit the best fit line. So my fake one that I drew there, those data points are really close to the line, so that would have a pretty high r value. An r value maxes out at 1. R's for this is 0.97. And look at the graph, and you can see we've got a pretty good fit. Okay? Because what you do to find the best fit line, what the calculator does, is it's a calculation that essentially, to oversimplify it, means you're going to have points same distance below the line as points distance above the line. Doing it on paper, you really just take a clear ruler and just eyeball that you have points evenly above and below the line. That's if we're graphing by hand. But if we're graphing in a calculator or Excel or on the LabQuest, we let the machine actually do the calculation, and then we have a perfect line. So with an R value of 0.97, what type of correlation would you say you have from those diagrams at the top of that page? That would be a high positive correlation. Okay? Now, one thing I want to point out, it shows you R equals 1. That's a perfect positive. It shows you R equals 0.8. That's a high positive. So anything from 0.8 up to 1 would be a high positive. And then, you get more scatter, but you still have a line, and it tells you R is 0.3, and it says that's a low positive. All right, but there's a pretty big range between a 0.3 and a 0.8. And this little diagram doesn't give us anything. Okay? So we need to recognize that we would have some sort of moderate or medium positive correlation in between there. Okay? So what? Probably our 0.4 we're probably still calling low, but our 0.5, 0.6, 0.7 we're probably calling a moderate or a medium correlation, anything below 0.8. It's not an exact cutoff. It's a range with some judgments in it. Okay? So what you need to do for the assignment is look at that last page. There are 6 graph axes, and on the page before, there are 6 data sets. Okay? So each person will do 2. So in your group, each person's going to do a different 2. Okay? So collectively in your group of 3, all 6 data sets will get done, but each person is only doing 1. So your group of 2, that just means 2 data sets don't get done. I want everyone to have practice on this, but it's not important that you see all of them. So you need to enter it into your calculator so that you can see the graph, and then you are going to sketch the graph. So it's not going to be perfect, but you need to put a title on your graph. You need to label each axis. You need to put in a few tick marks and at least one number so that someone knows what your scale is. Don't put in too many numbers. It just gets it all jumbled up. 1 or 2 is enough so that people have an idea of what your scale is. Okay? So you're going to put on, your dots and draw your line. And it's not going to be perfect, and it doesn't have to be perfect. You need to put down your R equals that the calculator gave you, and then your conclusion of high, medium, low, positive or negative, whatever it is. Make sense? Okay, so everyone's going to be turning in a paper with their name on it, but yours are only going to have 2 graphs. Now, if you would please, if you are doing data set 4, do it on graph 4. Match the numbers, because that's going to make it a whole lot easier on me when I look at these.
So if we're missing your first and